Welcome to This Explainer. Today, we're diving into a bizarre cosmic flash that literally took the entire astronomy world by surprise. And honestly, it holds some absolutely fascinating clues to the evolution of our entire universe. If you've ever looked up at the night sky and wondered about the sudden, violent lives of stars, well, you are definitely in the right place. We're going to look at a specific event that completely shattered astronomical records and kind of flipped what we thought we knew about stellar explosions right on its head. Let's get into it. So, what exactly happens when a star flickers like a flashlight? Imagine a star that bursts so bright you can see it with your naked eye, only for it to vanish back into the dark almost immediately. Normally, when we talk about cosmic events, we're dealing with timelines that span thousands or even millions of years. But what happens when the universe acts with the sudden flicking speed of a flashlight just being clicked on and off? It's a question that recently had astrophysicists absolutely scrambling for their telescopes. Well, this exact scenario played out on June 12th, 2021. A sudden, blinding celestial flash erupted in the night sky, spotted by Japanese amateur astronomer Seiji Ueda. It was so brief, it wasn't even on the radar of professional observatories. The whole astronomy world was taken completely by surprise. And it's just a wonderful reminder that even today, citizen scientists armed with the right tools still play an incredibly important role in discovering the universe's hidden secrets. Section 1. The record-breaking flash. Let's look at exactly how this discovery completely shattered astronomical records. Because, guys, this wasn't just any regular stellar outburst. What's really wild here is the sheer speed. This star system, known as V1674 Hercules, flared up and then faded in just over a single day. That is unbelievably fast. In fact, it absolutely destroyed the previous speed record, which was set 3 decades ago back in 1991 when a nova called V838 Hercules faded in about 2 to 3 days. Usually, a bright nova fades over a couple of weeks, sometimes even longer. So for this to happen in roughly 24 hours, that makes V1674 Hercules an exceedingly rare and precious subject for scientists to study. Moving on to Section 2, Anatomy of a Nova. To understand how a star can just flick on and off so incredibly quickly, we need to break down the mechanics of this explosive cosmic engine. Basically, it comes down to this kind of parasitic 3-step process, where a dead star's core feeds on its neighbor until it triggers a massive explosion. Step 1, we have a binary system, so 2 stars. One is a dense white dwarf, which is the leftover core of a dead star. This dense dwarf has a massive gravitational pull, literally sucking matter away from its companion star. Step 2, as that stolen material piles onto the white dwarf, it gets superheated. And then, step 3, all that intense heat and pressure trigger a massive, completely uncontrolled thermonuclear reaction. Boom! It releases an incredible burst of energy, shooting matter out at high speeds, which we see here on Earth as a brilliant flash of light. Section 3, a pulsing cosmic mystery. Now, the blinding speed of V1674 Hercules was really just the first clue in a much larger detective story. The speed was weird, for sure, but what astronomers noticed next was honestly even stranger. Researchers discovered a bizarre 501-second wobble ringing through the system like a reverberating bell. Exactly 501 seconds. Over and over and over again. Imagine striking a massive cosmic bell and just watching it vibrate. That is exactly what the light and energy from the star system were doing. But here is the truly baffling part. Researchers found this continuous wobble existed before the outburst, during the explosion, and a full year later. This 501-second oscillation was visible across different spectrums, showing up in both X-rays and visible light waves. I mean, really think about that for a second. An explosion so violent it blasted matter out into the cosmos, shining bright enough to be seen with the naked eye from Earth, yet this steady, rhythmic pulse just kept on ticking right through the whole shebang, even when the system was some 10 magnitudes brighter. It is a profound mystery that scientists are still scratching their heads over today. And this perfectly illustrates the ongoing puzzle that scientists from ASU, the University of Minnesota, and Ohio State are currently wrestling with. Not only is there this persistent 501-second periodicity regardless of the star's brightness, but researchers are also tracking strange, totally unexplained cosmic winds that are shaping the surrounding space. They've noticed that this wind, and the way the ejected material actually flows, seems dependent on the exact physical positions of the 2 stars. It's a highly complex, dynamic environment that completely defies our conventional models. Which brings us to Section 4, seeding the solar system. Now, you might be wondering, why does a distant, flashing star actually matter to us? And hey, it's a fair question. Let's zoom in on how these specific astronomical events directly built our own world. Just listen to this quote from Sumner Starfield, an astrophysicist at ASU. He says, "We're fairly sure now that a significant fraction of the lithium that we have on the Earth was produced by these kinds of explosions. This connects the cosmos right back to you. The lithium in our planet, and maybe even the lithium powering the battery in the device you're watching this on right now, was forged in exactly these types of nova explosions. When we ask where the chemical elements in our solar system came from, the answers often lie right there in the fiery outbursts of distant binary stars." Think of these white dwarfs almost like cosmic chefs. They don't just hoard matter, they take it in, subject it to immense heat and pressure that totally alters its chemical makeup, and then they blast it back out into space. They are quite literally seasoning the surrounding universe with newly formed chemical elements. Over billions of years, this ejected material clumps together, eventually forming new stellar systems and planets. It's this exact cycle of cosmic recycling that ensured our Earth formed as a rich, chemically diverse planet, rather than just a dead, floating lump of carbon. All right, Section 5, Measuring the Universe. Let's zoom all the way out to see how these tiny, ultra-dense stars allow us to measure the entire cosmos, because the implications here go way beyond just local chemistry. So sometimes a white dwarf doesn't shed all of its collected matter during a regular nova explosion. With each cycle, it gains more and more mass. Eventually, it becomes completely unstable and triggers a Type 1a supernova, literally one of the brightest events in the universe. We call this a standard candle. And why is it standard? Because every single time a Type 1a supernova happens, it reaches the exact same level of extreme peak brightness. No exceptions. And because these standard candles all burn at that same intrinsic brightness, scientists use them as cosmic mile markers. As Professor Charles Woodward from UMN explains, by looking at how the brightness of light changes, or basically how dim these standard candles appear to us from Earth, we can figure out exactly how far away they are. This gives astronomers an incredibly precise measuring stick to map out the overall three-dimensional structure of our universe and even track how fast it's accelerating outward. All of that profound cosmological knowledge stems directly from the behavior of these volatile white dwarfs. By utilizing advanced observational equipment, astronomers are using these distant binary systems as ultimate cosmic tools. These novae serve as living laboratories, allowing scientists to watch the raw, extreme nuclear physics of creation and death happen in real time. They let us test theoretical concepts out in the wild, and they reveal the still kind of mysterious process of how binary star systems actually evolve toward their ultimate demise. So, from a blink and you miss it flash, spotted by a dedicated citizen scientist, we've unpacked the creation of vital elements on our home planet and the very tools we use to measure the expansion of the cosmos. It's a lot to take in, and it leaves us with one final profound thought to ponder. If a single fleeting flash discovered by an amateur can explain the lithium on Earth and the expansion of the universe, what other cosmic secrets are waiting just out of sight? Keep looking up, stay curious, and thank you so much for joining us for this explainer.